Right, welcome to Peak Live, our first maths online lecture. So today what I'm going to be trying to do is teaching you guys how to do some basics of algebra. My name's Kevin and let's get on with it. So let me share my screen with you and then you'll see me in the top left. And what you guys can do is you can just send some messages if you have any questions on the poll, well not on the poll, but in the comment section below. And basically then what we can do is, I can answer your questions at the end. So how it's going to work is we're going to do a 40-minute maths lecture where I'm going to discuss some of the concepts with the algebra. So we're going to talk about basically simplification, factorization, solving equations, things like that. So hope you guys enjoy and let me know any questions at the end. Right, so fundamentals of algebra. This is what we're going to be covering today. And yeah, let's get in. So the first thing I'd like to cover with you guys is simplification. So if you're not familiar with algebra, please just watch along and see if you can pick up a few cool little tips and tricks on how to do some of these concepts. So the first thing is simplification. Right, now simplification is all the process of grouping like terms. Now, what is a term? A term is something defined by a particular algebraic variable or set of algebraic variables. So things like x, that is a term. Y is a term. Z is a term if you ever get to z's. And we can have multiples of these terms. We can add terms, we can multiply terms, divide terms, subtract terms, we can square terms even. But basically what happens is you have different levels of terms. So for instance, you have x squared would be a completely different term because it's a different number. Now, what are these x, y's, and z's? These are known as variables. And variables can be any number that you'd like them to be. So for instance, if you had to calculate something, you'd say, okay, I want to know what is 10 squared? That is equal to 100. X squared is basically taking in place any possible value that you would like it to be. So if x was equal to 4, then you would get x squared equal to 16, because 4 squared is 16. Now, when you're working with simplification, what we're trying to do is join terms together. So for instance, if we have, let's see, 4x plus 6x. Now, if you ever look at any maths textbooks or anything like that, you'll probably find that they have something along the lines of, if Jimmy has 7 apples and if he buys another 3 apples, how many apples does Jimmy have in total? 10, right? So over here, if we have 4x's plus 6x's, we can combine these because these are like terms. Right, so like terms you can add together, and so you can add them together, 10x. And if you have other terms multiplied to this, so for instance, if we have 4xy plus 6xy, these are also like terms because they both have one x and one y, one x and one y. And so you can add those together to get 10xy. Right, now when can you not simplify? And this is when you have unlike terms. Oh goodness, unlike terms. So that is, for instance, if you have 4x plus 4y. This is an example of a question or an expression that you cannot simplify because you have two completely different algebraic variables. So the x is not the same as the y because you can actually make them as two separate values. However, you can still use this as a calculation if you assign values to x and y. So for instance, you could use 4x equal to 4 and y equal to 3, and then you can solve this and get a numerical answer. But if you're just doing plain algebra, this is the most simplified form. Right. So if you have any questions relating to simplification, please keep them to the end and we'll get to them probably in the next 30 minutes or so after I've covered the rest of these topics. Right, so that's simplification done. The next thing I would like to discuss is expansion. Right, now expansion deals with brackets. Now expansion relates to brackets, like I said, and multiplication. So sometimes when you have grouped terms, so if something that looks like this, and now when you have grouped terms with inside brackets, this is sometimes known as a binomial, by having two terms. But when you have these two, you can actually get rid of the brackets by doing a process called expansion. So when you have some number, okay, or some term next to a bracket, like this 3 is, what that is called is an implicit multiplication. Okay, and what implicit multiplication means is that you need to take this 3 and multiply it to every single term in the bracket. Okay, I hope you guys remember BOD maths, very, very important. So in this case, if you had like terms within your bracket, first simplify, and then you expand your bracket by doing your implicit multiplication. So this expression can be expanded to form 3x plus 3y. Okay, pretty simple, but really effective little process. So if we look at some other examples of expansion, you can get more complex things. So for instance, if we had an algebraic variable and a constant multiplied by the same bracket, we have to do the same process where we multiply in and each term gets multiplied by the 3x. So that would expand to 3x times by x plus 3x times by y. Now, this is where we get to a very interesting part. What happens here? Okay, if we have x times by x, what does that mean? Can we write that in a different way? And we can. We can write that as 3x squared. Okay, because if you have, say for instance, 3 times by 3, that is the same as saying 3 squared. Okay, so if we have x times by x, that is the same as x squared. So here we've simplified our term by combining our grouping or combining our variables into a singular term. And for this one, we can do the same thing, except here, these aren't like terms, so we can't combine them to get a high indice or exponent. So what we do here is instead of writing this multiplication, we can just write it like this, 3xy. And basically what that states is that 3 is multiplied by x, which is multiplied by y, which is a general algebraic expression. Okay, so you don't need to write multiplication between algebraic variables and numbers. You can just write them next to each other, and that means multiply. Right. So let's take a look at another example of expansion. Right, so this is a slightly more complicated example of expansion, but generally when you're expanding, what you need to do is a process of expansion and simplification. So let's expand this one together. So firstly, we have this implicit multiplication. So we're multiplying the 3 into these two terms and the 5 into these two terms. So we do the expansion step. So we get 3x, and 3 times by minus 4 gives us minus 12. So notice that the sign belongs to the term on its right. And we do the same thing here. So plus 5 times by x is 5x, and 5 times by minus 4 is minus 20. Right, now we have to do the simplification step. So if we take a look, we see we have one x term, two x terms. Okay. And so we can combine those to form 3x plus 5x is 8x. And we can do the exact same thing with the numbers, the numerical terms. So if we got minus 12, minus 20, we combine those, that'll form, you guessed it, minus 32. And then there's our answer. Alright, so we can go even deeper into expansion. So some of you might have heard of a squared binomial term. So that looks something like this. Now, a lot of people tend to struggle when you're dealing with these sort of things. And I forgive you if you think it looks a bit tough, but it's actually really simple. So what we have to do is when you have something that is squared, right, always just write it twice if you're ever feeling unsure. So what we can do is the same as saying x plus 2 times by x plus 2. Right. And we know from algebra that we don't need to write that multiplier. We can just write it like this. X plus 2, x plus 2. Now, who's shouting out, oh, I know how to do this, I know how to do this. Right? You can tell me what the solution to this would be. That's kind of a rhetorical question, right? Because you're going to give me questions at the end of it. So, the answer is FOIL. And this is the next thing we're going to learn. So FOIL is a process of expanding two binomial bracket terms. Okay? And the rule is really simple. The F stands for first. The O stands for outer. The I stands for inner. And the L stands for last. And this is the basic process on actually expanding these terms. So if I just show you using some arcs and some nice color, the first two terms will multiply. So x times by x. And then the outer terms will multiply. So the x will multiply with plus 2. Then we continue and we can see that the inner terms will multiply, plus 2 and x. And then finally the last terms, plus 2 and plus 2 will multiply. So if we follow this process, we're going to get x squared, because x times x is x squared. And then we do the outer terms, so x times by 2 is plus 2x. And then we continue with the inner terms, plus 2 times by x gives us, well, 2x. And plus 2 times plus 2 gives us plus 4. And those of you with a very keen eye will notice that we need to simplify because these two terms are common. They have the same variable, so that means we can put them together. And so we get x squared plus 4x plus 4. Right, so we don't necessarily need to do this with squared brackets. We can do this with any brackets. So for instance, if we had a term like this, x plus 3, x minus 4, we can expand this in exactly the same fashion. So let's see if we can do it. So firsts, outers, inners, lasts. So let's expand it together. So the first two terms are going to be x's. So x times x is x squared. Our outer terms are going to be x times by minus 4, which is minus 4x. Our inner two terms are 3 and x. So we're going to multiply those to get plus 3x. And then we have our outer terms, our last terms, which is going to be plus 3 times by minus 4. Now 3 times minus 4 equals to minus 12. And then we've got to do a simplification process. X squared minus x minus 12. Now you may notice that here, if you go 4 or minus 4 plus 3, it actually gives you minus 1, but I haven't written a minus 1. And it's because it's implied. If you have a negative variable, it's the same as saying minus 1 times that particular variable. Right. So if we look at all of the expansion, generally the process is the same. You first expand by multiplying out your brackets, and then it's a case of simplifying so that you have the most simplified algebraic expression possible. Now let's kick it up a notch and look at an even more complex expansion. So let's look at expansion with a binomial and a trinomial. So a binomial means 2 terms, and a trinomial means a 3-term expression. And you agree we can't necessarily do FOIL here because, well, we've got firsts, we've got outers, we've got lasts, but then we've got a whole lot of inner terms. So we can't really do that. So what we're going to do is a process very similar to FOIL, and basically just making sure that every term multiplies every other term. Okay, so take a look. This term needs to multiply every term in the other bracket. Here. And we got this one as well, multiplying with the minus 2. Right, so that will multiply for all 3 of those terms, and then we can do the exact same thing with the plus 2. That's going to multiply. This will multiply. And now I've used all my colors. That will multiply. Right. So I won't do a 4-term one, otherwise we're going to have to repeat colors and that won't be great. So let's expand. So we're going to get x times x squared. Now, if you know your indices, you'll know that you can add the indices, x to the power 1 plus x to the power 2. That will give you x to the power 3. Then x times by 3x. That's going to be 3x squared. Then we have x times by minus 2, which is minus 2x. And then we do the same thing with the 2 and we multiply all these terms. So 2 times by x squared gives us plus 2x squared. And 2 times by plus 3x gives us plus 6x. And then last terms, that will be plus 2 times minus 2, which is minus 4. Quite a nice rainbow we've got going there. Now we have to do the simplification step. So are there any other x cubed terms? No. So x cubed stays as it is. Now we look for all the x squared terms. We have this one and this one. So we can combine them because they're both the same. They both have x squared. So it's going to be 3 plus 2 is 5 x squared. Then we look for all the x terms. Is minus 2x plus 6x. And so that will give us plus 4x. And then lastly, we have constants, and there's only one of them, so it's going to be minus 4. And there we have successfully expanded a binomial with a trinomial. And simplified and got the final answer. Right, very good. Okay. Now the second last section that I'd like to cover is factorization. Unfortunately, we won't have enough time to do indices and solving equations, so we're going to have to wait for next time to be able to do that. So the last thing I would like to cover is factorization. Factorization is quite an interesting process because it involves reverse expansion. Okay, so it's basically taking terms that are like or factors, so factor is basically like if you had to multiply two numbers or two terms to get to a particular term, then they are known as factors. So let's make an example of that. So let's take a look. So we have xy. Do you agree that means x times y? Okay, so therefore we can say that x is a factor, so is y. And if I had to multiply this by 4, then 4 would also be a factor, and things like that. Now, if we take a look at some numbers, you can also break numbers into factors. And this is known as a factor table. So what are the numbers that make 16, for instance? Well, we know that 1 times by 16, so it gives you 16, so therefore 1 and 16 are both factors. We know that 2 times by 8 also gives us 16, so 2 and 8 are factors. And 4 times by 4 gives us 16, and so 4 itself is also a factor. So this is just a numerical example of factors. This one above was an algebraic example. Now, factorization doesn't necessarily mean splitting up a particular term. It's actually how we group terms into a bracketed expression, and basically taking out a factor that is common in both of our terms. So let's look at an example where we do factorizing to separate common factors from two terms. So take a look at this example. xy plus 4x. Now let's see, what is a common factor between these two terms? Well, we see that the x is common to both terms. And because it's common, we can factorize it out, x, and then we open up our brackets. And now, inside the brackets is where we place all the leftover bits. From the factorization. So what will be left over from the first term? We see that this y would be left over, and so we put it in the bracket. And then from the second term, we see that the 4 is left over. And there we have fully factorized these two terms. Okay, well, we fully factorize this expression. Right, and the nice thing about factorization is you can use expansion to check that you have done the correct thing. So if we had to expand, we would see that we would have x times by y gives us xy, and x times by 4 gives us 4x. So therefore we are correct in our factorization. Let's take a look at some more complex examples of this. Okay, so let's add in another term here. So here we can see that all three of these terms share the x. Okay, so that's pretty nice. So we can factorize out that common factor. So I'll take out the x and then I'll open up my brackets. Now, what are the leftover bits? We see that we have a 4, because 4x gives us an x times by 4. And we have 7y left over here. And the last one is going to be 81yz. Okay, and there we fully factorize this one. Now, it doesn't always have to just be an x. It could be multiple bits of the actual terms that we can factorize. So if we look at this example, it will be more than just a singular x. Terrible choice of number. 8x plus 16x squared. Okay, so slightly harder example, but let's take a look. What is common between both of these terms? Now this is where knowing what the factors of 16 is, and that's where it becomes really helpful. So we see that 8 is a factor of 16. So if I take out an 8, I know it can divide into 16. No problem, because it's a factor. And then I can also see that x is also a factor for both of these terms. The first term has a singular x, and the second term has two x's multiplied. So we can take out 8x from both of these terms. And so if I've taken out an 8x, what am I left with over here? I'll let you think about it for a second while I take a sip of my coffee. Hopefully you're correct and you thought that it would be left with a 1. Okay, if you divide anything by itself, you get 1. So also if you had to multiply in, 1 times 8x gives us our 8x. And so therefore 1 is left inside the bracket. And then plus. Now, if I've taken out an 8 from the 16x squared, what does that leave me with? Well, 16 divided by 8 is 2. And if I take out an x squared divided by x, well, we haven't covered that. But we know that if we had to multiply an x by an x, we're going to get x squared. And so I'm left with 2x as my second term in my bracket. And there we have fully expanded. There we go. So there's some more complex factorization. Okay. Now, there are a couple other rules that are really interesting that you can learn about factorization. So what we've done is basic factorization, but there are two other ways that we can do factorizing, and this deals with quadratics. So some of you may have heard of dots. Okay, and what dots represents is the difference between two squares, or difference of two squares. Let's go with that. That would be DBTS, and that doesn't have the same ring as dots does. The difference of two squares. And what would be two squares? That's quite weird. Are we dealing with shapes here, or we're dealing with algebra? And a square is basically just a squared number or a squared term. So examples of this would be like 4 squared, okay, which is 16. We can do 8 squared, which is 64. I'm sure you guys know your square numbers pretty well. You can also have algebraic variables squared, so x squared, y squared, x squared, y squared, that's also a squared one. So any of these would be squares. And then what does the difference imply? Subtraction. So basically, if we subtract two squared numbers from each other, we could factorize them if they are squares. So let's look at an example. So if I had x squared minus 4. Now 4 is kind of a square number in disguise because the square isn't shown, but we know that 4 is 2 squared. So you can write it in that fashion. X squared minus 2 squared. Right, so we have difference of 2 squares, right? Perfect. Now you should be shouting, Kevin, that's great. You've told us that we've got the 2 squares subtracted from each other, but what do we actually do? How do we factorize this thing? And I'll show you the rule. So if we have x squared minus some constant squared or some other term squared, that is equal to x plus a, x minus a. And wow, this is quite a complicated factorization because we have these two terms and then we end up getting two separate brackets from it. Super interesting. So that is the rule, and super helpful rule as well. So let's put a little square block around that, or rectangle around that, and let's actually apply it to our question. So if we're following the rule, we see that we're going to get open bracket x plus 2, close bracket, open the next bracket, x minus 2. And that is fully factorized. Now remember, you can always check your factorization to see if you actually did the correct thing. So why don't we expand this and see if we got the correct answer. So remember, we're going to do FOIL, so it's the firsts, the outers, inners, and the lasts. You guys must be getting good at FOIL by now. So we're going to have x squared plus 2x minus 2x and minus 4. And we notice we've got to do a simplification step. And so the 2x and the minus 2x cancel. So we're going to get x squared minus 4. And that is exactly what we started with. So therefore, this is correct. And that's the awesome thing about some maths, is that you can actually check yourself to see that you actually got the correct answer. So there's no reason to get any factorization questions wrong, okay? Because you can always just expand and see, okay, did I get what I started with? And if the answer is yes, then you have factorized correctly. Okay, let's take another example, a slightly more complex example of difference of two squares. Let's see if I can find a good one for us. Right, try this one out. 81h squared minus 16g squared. Right. Sure, this looks hectic. So, is this a difference of two squares, firstly? Well, let's take a look. We've got 81, which is 9 squared. And we've got h squared, so that makes a square number. Great, sorted with that one. And 16 is 4 squared. So therefore we have another squared number. So therefore we do have difference between, or difference of two squares. Tick. So now we just need to apply the rule. So let me write it again for you guys. X squared minus a squared equals to x plus a, x minus a. Okay, so let's apply the rule. So we're going to have, now this forms our x term, right? And we see that it's going to be 9h, right? Because the square root of 81 is 9, or 81 is 9 squared. So it's going to be 9h plus, now 16g squared, we can write as 4 squared g squared. And so it's going to be 4g. And then same thing here, 9h minus 4g. There we have done difference of two squares and factorized. Now, you can notice something. Let's see. Have we fully factorized? Because that's generally the question, right? And so if we take a look, we can see that we have another difference of two squares. Who noticed that? You can tell me later, right? So you can see we've got 9h plus 4g. That's not a difference because it's addition. But here we have another pair of square numbers. Oh, actually we don't. Oh, that's sad. I got excited. It's because we don't have h squared, so we can't do it. But we did have 9 and 4, which are square numbers. And so if we had h squared and g squared, we could have done difference of two squares again. So in fact, we have fully factorized. I jumped the gun. So what I'm going to do is I'm going to stop right there. Okay, I'm not going to do any more complex factorization. Perhaps in the next lesson we can look at slightly more complex ones when we actually do some quadratics and we talk about solving equations and things like that. And so that's where I'm going to end this off. So I'm going to open the floor to Q&A. So if you have any questions, feel free to ask, and I'll try to answer them the best that I can relating to simplification, factorization, and expansion. If you have any questions, please feel free to leave them in the comment section below, and I'll see if I can answer them in this live stream. If I can answer them in this live stream. Okay, well, while we're waiting for some questions, may as well do some questions on my side. So let's take a look at some simplification examples. Oh, I just got a question. How exciting. Right. So, got a simplification question, and just so happens that I'm doing a simplification example. And the question is quite a complex one, so let's take a look at it. So we have 3x squared plus 4x squared minus 7x plus 8x, goodness, this person gave me a long one, plus 9. Right, so this one looks quite interesting, and we can see that we can simplify this one quite easily, because we just see that there are two sets of terms that we can combine to form a singular term. So all the x squared terms get combined together, and that gives us 7x squared. And then with the other terms, the x terms, we can combine those together. Minus 7x plus 8x gives us x. Because remember, the 1 is implied, we don't need to write it. And then there are no other constants, and so that combines together. And there is our simplified term. Right, let's take a look at another question. Someone with the IG textbook can actually tell me one or two if they have any questions from that. Yeah, to have it, which is quite nice. So I've got this simplification question, and let's see if we can tackle it together. So we've got 3xy squared plus 4xy plus 11xy squared minus 2xy. So this one looks pretty complicated because we have x's and y's and y squareds, but again, super simple in the sense that all we need to do is look at what is common. You see we have this 3xy squared, and we have this 11xy squared, and so those combine to form 14xy squared. And then if we take a look at the 4xy and the minus 2xy, those also combine to form plus 2xy. And that is our simplified expression. Okay. Again, if you have any questions, guys, please feel free to leave them in the comment section, and my assistant will let me know what the questions are. Right, let's take a look at some expansion examples. Right, so expansion is actually absolutely fun because we're busy multiplying out some brackets, and everyone likes multiplication a whole lot more than adding and subtracting. So let's take a look at this question. 5x multiplied by x plus 7y minus 2x times by 2x minus y. Right, so this is an expansion example, and if we remember back to what I said earlier in our lecture, expansion requires us to multiply our brackets and then simplify afterwards. So let's do some multiplication. So the 5x is going to multiply to the first term and to this last term in the binomial bracket, and the same thing with the minus 2x. Just remember, the minus belongs with the 2x. So that multiplies there and there. So 5x times by x, well, we know that x times x is x squared, and so it's going to be 5x squared. And then we have 5x times by 7y. Now 5 times by 7 is 35, and x and y. They aren't like term, well, x and y aren't like, so we can just show that they multiply each other. And then we have minus 2x times by 2x gives us minus 4x squared. And then minus 2x times by minus y. Now, a minus times a minus is a plus. So plus 2xy. And here comes the next step, which is the simplification process. So we need to look and see, do we have any terms that are common, that are the same? And we see, yes, we do. We have the x squared terms, and we have the xy terms. So if we combine those together, we get x squared. So 5x minus 4x gives us x squared, or 5x squared and minus 4x squared. And then if we have 35xy plus 2xy, that gives us plus 37xy. Okay, I just received another question. This is quite cool. So it's relating to expansion, and it's a slightly more complicated one. Seems to be getting a whole lot of complicated questions from you guys, but that's great. Let's take a look at it. So this student sent me this question, which is x squared times by xy plus 3 minus xy times by x minus 7. Sure, okay, so slightly more involved question, but let's see if we can work it out together. So we do the same process. We multiply into our brackets by this x squared into each term, and then the same thing with the minus xy, and that multiplies into the brackets too. So that multiplies like that, and this multiplies like this. And I don't think you guys need me to remind you that the minus belongs to the xy. So let's do it. And x squared times by x gives us x cubed, and then times y, and we get y. And so x squared times by 3 gives us plus 3x squared. And then here we have minus xy times by x gives us minus x squared y. And then lastly we have plus 7xy. Now this is quite an interesting question because we actually don't have any opportunity to simplify. It looks like we might, like it's close. We've got x cubed and x squared, and they're both multiplied by y. But because we have 3 x's on this one and 2 x's on that, they're not like. And likewise here, these two can't simplify any further because this term is missing out a y term. And then lastly, same thing over here. There is no other term that it shares with, and so that is fully simplified and fully expanded. Okay, while I'm waiting for another question, let's take another look at another expansion example. And this time, this one is dealing with 2 brackets. Right, so this is one of those questions that I showed you earlier. So let's see if we remember how to do it. Okay, so the process isn't FOIL, but it is relating to FOIL by multiplying every term by every other term. So these two are going to multiply. So it's these ones, and then we do the same thing here. Right, and now we just need to do the multiplication process. So 2x times by x squared gives us 2x cubed. 2x times by minus 4x gives us minus 8x squared. 2x times by 2 gives us 4x. And now we move on to the minus 3. So minus 3 times by x squared gives us minus 3x squared. Minus 3 times by minus 4x. Ooh, well, minus and a minus makes it a plus. And so we're going to get 12x. And then lastly, minus 3 times by plus 2 gives us minus 6. And now from this, all we need to do is now simplify. So, do we have any x cubed terms? No. So, we cannot simplify that any further. X squared terms? Yeah, we do. We have two of them. We have minus 8x squared and minus 3x squared, which gives us minus 11x squared. Then we take a look at x's. We have 4x and 12x. Combine those together to give us 16x. And then lastly, we have the constants, of which there's only one, and so it's going to be minus 6. And there is our fully expanded and fully simplified algebraic expression. Okay. Right, only got 12 minutes left, so then we should move on to some factorization examples. Right, so let's factorize the following. So I've just got a question here. So we have 6xy minus xy plus 3y. Okay, quite an interesting question. Right, so if we take a look at this one, we can see that we actually can first simplify by combining these two terms together. Because once we've done that, then what we can do is factorize out y from all the terms, right? Because y is the common factor in every term present. So let's take a look. So 6xy minus xy is going to be 5xy plus 3y. Now we look at what is common, and like I said earlier, the y is common in both terms. So we can factorize out the y term, which leaves us with 5x plus 3 in our bracket. Okay, and there's quite a question now relating to factorization, which is pretty cool. So thank you very much for that question. Right, let's take a look at this one. xyz plus x squared y minus 2xy. Okay, quite an interesting question. Okay, so we have a mixture of x, y's, and z's, and we've got x squareds. So let's take a look. So what is common? That is the general question that you should be asking every time when you're trying to factorize. What is the common factor between all three of these terms? So if we take a look, we see we've got an x, and an x. So therefore we can take out an x from all three of these terms, and the same thing with the y's. And there we go. Those are the common factors between all three of these terms, and so let's take them out. xy, open brackets. So what does the first term leave me with? What's the leftover bit? It's going to be the z. Then here, the second term, this is probably the more complicated term, because we have x squared y. So So if we're taking away an xy from this term, that means we're going to be left with only x. And then the last term, that one's quite nice and easy. We get left with a minus 2. And there is a fully factorized expression. Right, let me take another look at another example here, and let's see if we can do some factorization. So we have 4x squared y subtracted by 2xz. Right, this is quite interesting. So let's see what is common. So we see that both of these terms share an x. So that's quite an easy thing to identify as the algebraic variables. But now what we need to do is to actually take a look at the numbers, right? The constant coefficients. Not just the coefficients, really. These numerical values in front of these algebraic expressions. So we see that we have a 4 and a 2. Now, I don't know about you, but I know for a fact that 2 is a factor of 4. And so we can take out 2 from the 4. And let's go for it. Let's take out 2x of both terms. So if I'm taking away 2 from the 4 in terms of division, that leaves me with a 2. And if I'm taking away an x from the x squared term, that leaves me with an x, and the y remains. And then from the second term, we see that the 2x disappears and we're left with a z. And that is fully factorized. Cool. I was hoping for some difference of 2 squared questions. So maybe let me find one and hopefully you guys will present me with 1 or 2 as well. So let's take a look at this. Sure. Okay. So here we have a supposed difference between 2 squares question. This is quite a hectic question because now we've got x to the 4s. Right, so let's see if we can actually write this in a squared notation so that we can see the difference between 2 squares, or the difference of 2 squares a little bit more easily. Now, I know that 81 is 9 squared, and I know that x to the power 4 is the same as saying x squared times by x squared. And so I can write this as 9x squared squared. Now we haven't had an opportunity to go through indices, but in the next lecture video, we'll definitely go through it and we'll explain how these work. And we can do the same thing here with this one. It'll be 5y squared squared. Now you guys know how to expand. So if we wanted to prove that these are the same, we can just write down our brackets twice. And we know that that is an implicit multiplication. So 5 times by 5 is 25, and y squared times y squared is y to the 4. That's just showing you that we can, in fact, write 25y squared, sorry, 25y to the 4 as 5y squared squared. Now we have to do the difference of 2 squares rule. So that means we're going to have 2 brackets. And the first term is going to be 9x squared plus 5y squared. And then in the other bracket, we have the exact same thing, except we have a subtraction. So it's going to be 9x squared minus 5y squared. And there we have successfully done the difference of 2 squares to factorize these 2 terms. Now let's see if I can make up an example that makes us do the difference between 2 squares, the difference of 2 squares twice. So we have 81 x to the 4, so same as before, except this time, let's see, what's the nice one? Let's try 16. 16 is a good number. Minus 16y to the 4. So here we have, again, same scenario as before, where we have x to the 4 and y to the 4, which we can write as x squared squared. So let's write that in that format. So it's going to be 9x squared squared minus 4y squared squared. And let's actually do the difference of two squares. So it's going to be two brackets, and we write down on 9x squared plus 4y squared. And then the same thing again, except we have a subtraction. So 9x squared minus 4y squared. Now, we have successfully found an example that has another difference of two squares. So we have to factorize it further. So we write our 9x squared plus 4y squared, and then this bracket will become two more brackets, bracketception. So we're going to have 9, which is 3 squared, and x squared is 1x squared, and 4 is the same as 2 squared, so it's going to be 3x plus 2y, 3x minus 2y. Right. And there we have our last example on factorization. Right guys, I think that's where I'm going to wrap it up. I don't think I have any more questions. Thank you so much for joining in. I really appreciate it. And yeah, I hope that this lecture actually helped you guys out and you learned a little bit more about algebra with simplification, expansion, and factorization. Thank you. Bye.